Lesson 9.5, Scientific Notation. This is a shorthand for very large and very small numbers. A long time ago, scientists and mathematicians came up with this way to save time when they were dealing with very large and very small numbers. And scientific notation is always in this form. It is some number, I'm going to call it A. That number has to be between 1.0 and 9.9. It cannot be anything else to be in the correct form. So it has to be something basically from 1 to 9, and if it's not, you have to fix it and make it something from 1 to 9. Well, the rest of scientific notation has times, and they usually use x times 10 to the n power. N tells how many places to move the decimal. So if you need to take a number in scientific notation and write it out in standard form, that means like a regular number, that's probably the easiest part of scientific notation because this makes so much sense. If n is greater than 0, in other words, if n is positive, you move that decimal to the right that many places. If n is negative, you move that decimal left. So basically, if this is a negative number, you're counting on that's going to be really a decimal value because that decimal is going to be moving this direction. So remember, if this is positive, you move it right. Negative, you move it left. Like I said, this is the easiest way because after this, then after that makes so much sense, then sometimes you get confused about the other directions. So let's start off with expressing these numbers in scientific notation in standard form. The first one is 3 times 10 to the 5th. So here's what I would do with this, is I would take 3. You don't see a decimal, so that means it's here at the end. And since it's times 10 to the 5th, what does the 5 tell us to do? Who wants to help me with this one? Stephen.
You move the decimal point right 5.
Move it right because it's positive 5 places. So I'm going to make these empty waves. 1, 2, 3, 4, 5. And Stephen, what always goes in empty waves? 0. So I'm going to put in these 5 zeros. And after you do that, you need to go back and kind of clean the number up. So Stephen, can you tell me what number that is? 300,000. Make sure when you give those big answers like that, those big numbers, you put the commas in so it's easier for everyone to read. Okay, 4.395 times 10 to the 4th. So again, I would bring that 4.395 like this, and now what are we going to do, Braxton?
Move the decimal right 4 places.
Move the decimal right 4 places. So here we go. 1, 2, 3, and 1 empty wave, Braxton. What goes in there?
0.
Okay, and then tell me what number is this at the end?
43,950.
43,950. All right, the last one in this section, 6.79 times 10 to the negative 6. So what's different here, Shane?
You're going to be moving the decimal place to the left.
Move the decimal place to the left. So I'm going to leave it right here where it is, and I'm going to move it 6 places left. Though there's 1 to get around that 6, but then I got to go 2, 3, 4, 5. The decimal goes right here. Shane, what goes in all of those zeros? I don't know if I've got enough there or not, do I?
No.
I don't. I need 1 more. Okay. So I went 1, 2, 3. I need 1 more. Okay. So there's going to be 5 zeros in front. And when you bring that out and write it, kind of clean it up a little bit. Shane, what? Maybe you can't read that number, but tell me what I should write.
0.0000679.
Yeah, 0.0000679. Okay, very, very small decimal. All right, so expressing it in standard form, you're moving the decimal left and right. it should be good. Questions on that? All right, now we've got to go in the opposite direction. We're going to express these in scientific notation. Okay, so the first one being 800,000, and you do not see a decimal in that, then that means the decimal is here at the end. Now, kind of just keep in mind, it is a whole number, it's not a decimal, and all the ones above, when it was a whole number, not a decimal, what was the exponent, positive or negative? Positive. So when you're doing this, just kind of keep in mind, you're moving the decimal left, but remember, since it is a whole number, you really need to have a positive exponent. So this gets moved 1, 2, 3, 4, 5. Now, I needed to make that a number between 1 and 9. So I got to take that decimal and move it all the way right here, so it's the number 8. And you can say 8 or 8.0, it doesn't really matter. I'm just going to say 8 times 10, and we moved it 5 places. Okay, let's look at 64,000. Who wants to try this one? Okay, Tori.
Just move after 64,000, so you move it to the left 3 times.
1, 2, 3. Now, is that number between 1 and 9?
No,
No. So
move to the left.
one more time, and you would write
6 times 10 to the...
well, nope, you got to say more than just 6. 6.4 times 10, 4 places we moved it. 6.4 times 10 to the 4th. So a couple things I want to mention. You don't write the extra zeros at the end. If you did that, that's kind of defeating the purpose of the shortcut, okay, the shorthand move of that. But anything that's not 0, you do need to include that. Now, if there was a 0 in between a couple of other numbers, then you actually do have to write those. But when they're at the end like that, you can just drop those all off. That's kind of the point of scientific notation. Okay, 0.00389 right here. It's a decimal number. What does that tell you about the exponent? It's going to be negative. You've got to move that decimal over until you get a number from 1 to 9. So if I move it one spot, it's still a 0 there. If I move it one more spot, it's still a 0. And if I move it one more spot, now it's 3 something. So that's how I know where it goes. And I would go ahead and write 3.89 times 10 to the negative 1, 2. I moved it 3 places. All right, so somebody want to help me with this one. 0.0119. Trayton, what am I going to do with it? Move it to the right. So if I move it there, is that far enough? Nope. Okay, what about there? Is that a number from 1 to 9? 1 to 9? Yes. Okay, so what would be the number that I write then?
1.19.
Yep. Okay. Negative second. We moved it 2 places. Negative 2. 1.19 times 10 to the negative 2. All right, let's finish off with one more. 759,000. Layla, what am I going to do with this one?
There's a 0 at the end.
Okay. The decimal at the end, right?
Yeah.
All right, and then
Go back 5 places.
okay, she says 5 places. So what number would we write?
7.59 times 10 to the 5th.
5th. Since it was a whole number, that's going to be a positive. That's right. Okay. Now, there's going to be some other things that we need to do here with these, with scientific notation, other than just writing them back and forth. Before I get rid of the stuff in red, are there any questions? Okay. It says choose the greater number. Well, this one's kind of an obvious one. Can anybody tell me why I feel like it's so obvious? Dakota?
Because one of them's positive, the other one's negative.
Yeah, this one has a positive exponent, which means it's going to be a pretty large number, or at least it's going to move that decimal to the right. This one has a negative exponent, which means it's going to move it to the left. It's going to be a decimal. So if you had to choose the greater one, then Dakota, what are we going to pick?
The one on the left.
The one on the left. 7.3 times 10 to the fourth would definitely be it. Now, obviously, I don't think they're all going to be that easy. So you would probably, if you don't know, maybe write them out in standard form and compare them that way. And that would probably be the best way to do it if they had the same or were close. Okay? They had the same decimal or exponent, or they were close. Order from least to greatest. Okay, so we've got to figure out 0.0048, 3.27 times 10 to the negative 4, 4.2 times 10 to the negative 3, and 0.04. Honestly, these I would definitely all write out in standard form and compare place by place. So this one's 0.0048. The 3.2 times 10 to the negative 4. The negative's going to make it move 1, 2, 3, 4 places over like that. So 0.0000327. And then 4.2 times 10 to the negative third is going to move that over 1, 2, 3. So 0.0042. The last one, 0.04. So if you look and you look at the place values, in the tens place, every one of those have what number? 0. In the hundredths place, there's a 0, a 0, a 0, but this one has a 4. What does that mean? That it's the biggest number in the list. Okay, so if I look at the thousandths place, this first one has a 4 there. This one has another 0, and this one has a 4. So does that help us to be able to come up with the smallest number? The thousandths place? Yeah, because the second one, it's still a 0. So it's the smallest. Yeah, but not with the 4s. But you can tell that this one is the smallest because the third place value is still a 0, where this is a 4 and this is a 4. So this one is definitely the smallest, and I would put 3.27 times 10 to the negative 4 first. Now, I don't know which one's the next smallest just yet. If I compare the first and the third one, the first one has, in the 10,000ths place, an 8, whereas the third one has a 2. So what does that tell me? Which one's the next smallest? Or I mean, I should make the biggest. So which one?
0.0042.
Right. So we're going to put 4.2 times 10 to the negative third. And we already said this was the biggest, so we're going to say 0.0048 and then 0.04. That's ordering from least to greatest. Make sure that you write them the way they were given to you. So if they were given in scientific notation, that's how you write them. Okay, questions? Everybody got that written? We've got one more thing to do, and this is kind of helping us lead into more what we're doing on Wednesday. Those numbers, at first glance, look like they're already in scientific notation, don't they? Because it's got the times 10. But what's really wrong with them?
Above 1 through 9.
Yeah, they're not 1 through 9. So when that happens, you need to adjust it, and this is what we're going to have to think about. If you move the decimal to the left, it makes the exponent go up, meaning that many more places to get it written out correctly. If you move the decimal right, it moves the exponent down. So this one right here, 25 times 10 to the 6th, I see the decimal must be here at the end. I'm going to have to move it one place to the left to make it 2.5. So my first part of it's going to be 2.5, but since I moved it that way, it's going to make the exponent go from 6 up to 7. Same way with 475 times 10 to the 5th. The decimal's here. I'm going to have to move it over 2 places. So 4.75, that's going to make it times 10 to the 7th. And then finally the last one. So this is supposed to read right in scientific notation. The last one is a decimal. We have to move it this direction, and every time we move it, that's going to make this go down, and we've moved that one twice. 2.7 times 10 to the 2nd.